Recovery was the prerequisite. Architecture is the objective. You have reset your baseline. Now you must learn to drive the engine without melting the circuits. Most of you are currently attempting to force focus through a process of cognitive brutalist, working against your own internal hardware. The result is ultradian stress syndrome. Nathaniel Kleitman discovered the basic rest activity cycle, or BRAC. He proved that your brain does not operate on a flat line. It operates in 90-minute waves. When you ignore the flicker, that moment of friction at the end of a cycle, you aren't being productive. You are triggering a cortisol spike that liquidates your dopamine for the rest of the day. We have processed the foundational research of Kleitman and the modern focus protocols of the Huberman Lab. Initiate Research Intercept, the architecture of the 90-minute wave.
You know the feeling, right? You're deep in the zone, everything's clicking, and then, poof, it's just gone. The focus vanishes, you hit a wall, and you're left wondering why your brain suddenly decided to clock out for the day. We've all been there. But what if I told you that moment isn't a failure? It's actually a biological signal. Okay, let's get into it.
And I mean really shut down. 1 minute, you're on fire, totally productive, and the next, you feel like you're trying to think through mud. It's super frustrating, and it feels so random, but it's not. It's actually your brain's internal clock trying to tell you something really, really important.
These are the classic signs. Researcher Ernest Rossi pointed these out as the signals you've pushed your brain past its limit. You start making dumb typos, you get weirdly angry about something small, or you just totally space out. This is what we're calling the focus wall, and it's basically your body sending up a flare, begging you for a timeout.
And here's the most important takeaway. Hitting this wall is not a personal failure. It's not that you're lazy or undisciplined. It's a feature of your biology, not a bug. Your brain is running on a hidden, predictable rhythm that controls your energy and focus all day long.
So, we've all heard of circadian rhythms, right? That's our big 24-hour sleep-wake cycle. But running underneath that are these things called ultradian rhythms. These are much shorter cycles of peak performance, followed by a period where you absolutely have to rest. You can think of them like a series of energy sprints that happen over and over again throughout your day.
So this thing actually has a name. It's called the Basic Rest Activity Cycle, or BRAC for short. It was first figured out by a pioneering sleep researcher named Nathaniel Kleitman. He's the one who realized that these cycles that happen when we sleep, well, they just keep on going when we're awake, affecting everything from how hungry we are to how well we can concentrate. And this is where it gets really, really cool. Check this out. It turns out that during one of these cycles, the two halves of your brain actually peak at different times. So your logical, word-loving left brain might be firing on all cylinders, while your creative, big-picture right brain is taking a nap. And then they switch. This explains so perfectly why some moments you're amazing at writing an email, but you just can't for the life of you figure out a design problem.
So all of this brings us to the main idea, the key to mastering your focus. If you can just understand the timing of these cycles, you can start working with your brain's natural rhythm instead of constantly fighting against it.
So what's the magic number for these cycles? Well, it's about 90 minutes. I mean, study after study on everything from mental performance to athletic stamina. This 90-minute cycle shows up again and again. It seems like our brains are just wired to go hard for about an hour and a half, and then they absolutely need a break.
I love this quote from neuroscientist Andrew Huberman. He says focus isn't like an on-off switch, it's dynamic. And as you get close to the end of that 90-minute cycle, your brain sends you a little signal. He calls it a flicker. That's the moment your mind starts to wander, you get that itch to check your phone. That flicker is a message. And right there, in that moment, you have a huge choice. You can ignore that flicker, chug more coffee, and just force yourself to keep going. Ernest Rossi calls that the ultradian stress syndrome, and it's a direct path to burnout. Or you can listen to it. You can take a real break, which triggers what he calls the ultradian healing response, letting your brain recharge so it's ready for the next peak performance cycle.
Okay, so knowing the science is great, but how do we actually use it? Well, that brings us to 3 super practical, science-backed protocols you can start using today to get a handle on your energy.
All right, protocol number 1 is called the visual anchor.
Think of this as a simple warm-up for your brain before you start a big task. It's designed to wake up the exact parts of your brain you need for deep concentration.
Here's all you have to do. Before you dive into your work, pick a small spot somewhere in the room, a dot on the wall, a screw on a chair, and just stare at it. For 30 to 60 seconds, that's your only job. Your mind will wander, just gently bring it back. Why does this work? Because your mental focus follows your visual focus. By locking in your eyes, you're basically telling your brain, hey, get ready, we're about to do some deep work. It's literally like a bicep curl for your attention span.
Okay, next up is what you do after your 90-minute work sprint. And honestly, this might be just as important as the work itself. This isn't just about taking a break, it's about taking the right kind of break.
So when that 90-minute timer dings, or you feel that flicker, you have to deliberately defocus. That means for 10 to 30 minutes, you do something that requires almost no brain power. Go for a walk, stare out a window, do the dishes. But here's the crucial part, what you don't do. Don't swap your computer screen for your phone screen. Scrolling social media or reading the news still requires focused attention, and it stops your brain from actually recharging.
All right, our third protocol is gonna sound a little weird, a bit counterintuitive. This is for those moments when you absolutely positively have to lock in right now. And it involves using a little bit of stress to your advantage.
A quick, sharp blast of stress, like a 1 to 3 minute cold shower or even just splashing cold water on your face, triggers a big release of adrenaline in your body. And what does adrenaline do? It naturally narrows your focus, creating a kind of tunnel vision, both for your eyes and your mind. You're basically hijacking your body's fight or flight system to kickstart an immediate, intense burst of concentration. It's perfect for when you're on a tight deadline.
Okay, we have covered a lot of ground, from brain chemistry to cold showers. So let's pull it all together into one simple, actionable playbook. Seriously, you might want to screenshot this for your next big project.
Here it is, nice and simple. First, plan your work in focused chunks of 90 minutes or less. Second, learn to recognize that flicker, that feeling of distraction or fatigue. Third, when it shows up, respect it. Take a real 10 to 30 minute defocus break, and yes, that means no phone. And fourth, before you start, do a quick 60-second visual anchor to warm up your brain. The main idea through all of this, stop fighting your biology, start working with it. Look, this 90-minute cycle is happening inside you right now, whether you pay attention to it or not. The only question is, are you going to let it run you into the ground, or are you going to use it to your advantage? Your next cycle is just around the corner, so what are you going to do with it?
The data is unambiguous. Focus is a pulse, not a marathon. To build cognitive equity, you must adhere to the stamina protocol. The era of grind is over. The era of biological optimization has begun. Join us next week as we decode the neural stack for deep sleep recovery.